Everyone, just wanted to take a minute to talk about how we can use the distance formula to solve for the perimeter of different shapes. In this case, we just have a quadrilateral here. So we can find the length of all the sides and add them together to determine the perimeter. All right, so this is an application of the distance formula. For those that recall, the distance formula, as you can kind of see here, if we sketch it out, just comes from right triangles, right? It comes from the Pythagorean theorem. So for us to recall, the distance formula is just distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so we're trying to find the total length that connects these towns. So ultimately what we're really being told here is we have a quadrilateral and we need to find the perimeter. And we're going to use the distance formula. Now, if we had lucked out, we would have gotten more than one side here that is either vertical or horizontal, but we only got one side that is like that. So let's, well, we can easily figure this out, right? So whenever you get a vertical or horizontal side, you really just have to count. Because you're only dealing in one dimension. There's no, change in y and change in x. So one of these is just going to end up being 0, and you're really just going to be looking at the distance from the x coordinate to x coordinate. So we go from 3 to 9, so this is a 6. So that one's easy enough. We're done with that one. Now, if there's anything else we can easily figure out before we go on our escapades of actually doing out the distance formula, let's see. So we know just from the quick way that I just sketched that, so we're going over 1 to 3, so this is 2. And we know we're going from 2 to 8, so this is 6, so nothing we can necessarily do there. We're going down 1, 1, 2, 3, 4, 5, 6, 7. So 1 and 7. So that is helpful. So we're going down 1, 2, 3, 4, 6, 7. So if I'm correct in double counting, 1, 2, 3, 4, 5, 6, 7. So since this is up 7 and over 1, these are two triangles with the same side lengths. And as I said, the Pythagorean theorem is how we derive this. So these lengths right here are going to be the same. And remember, the dash or the slash in the line just means that these are congruent and they'll have the same measure. And again, we can use the Pythagorean theorem to verify that because the distance formula just comes from the Pythagorean theorem. So look at that. We've already covered this side. Good. We know once we get this side's the same. So that side doesn't matter. And then this one we do actually have to just do on our own. All right. So let's just start from, let's just go the distance from A to D. All right. So this is the one that we don't know anything about yet. This one's on its own. So we're going from, I'll just call this x2, y2, x1, y1. Now it doesn't matter which one I go with first because it's squared. And so that'll deal with any of the negatives anyway. You just have to be consistent. So we're going to do 3 minus 1 squared plus 8 minus 2 squared. And you'll notice that this is just the same thing as 2 squared plus 6 squared. So that was all I found here, right? So I don't even have to worry about plugging in the rest of these points for these other ones. I already know what it is, right? When I plug in the points, it's just 2 squared, 6 squared, 2, 6, right? So, because again, this just comes right from the Pythagorean theorem. 4 plus 36 equals the square root of 40. Now, I'm not going to leave it as the square root of 40. we know how to simplify this. This is the same thing as 4 square root of 4 times the square root of 10, which is 2 square roots of 10. All right. Now, as I said, the length from A to B is the same as from B to C because, again, it's 1, 7, 1, 7. Using the Pythagorean theorem, you know that C is going to be the same. So whatever I get for A to B, I'm going to get for B to C. Okay. So using that little trick I just showed you last time where I said because this is the Pythagorean theorem and we know when we plug in the points, it's just 2, 6. I already counted, so we're just going to essentially have the square root of 7 squared plus 1 squared. All right. And if you plug in the points, you will just get that. I assure you. So that would end up being 49 plus 1 square root of 50. Now again, we're not going to leave that like that. That's the square root of 25 times the square root of 2. So that is just 5 root 2. Now again, we're dealing with 2 of these. So when we add everything up, remember we have to add that twice. So the perimeter or the length is ultimately 6. Don't forget our 6 from the top. Plus 2 square root of 10. And then plus 2 times 5 times the square root of 2, which is 10 square roots of 2. Now you can plug this into a calculator, and this is miles. If you want to get a rounded answer, obviously, it doesn't necessarily help for me to tell you it's the square root of 10 miles. But ultimately, without going through and plugging everything into a calculator, this is good enough for our purposes. And just as a quick heads up, in case you did not believe that if I plugged it in the points or if I had found this on its own, I want you to verify that for me. So if you don't fully believe me that I'm saying that AB is equal to BC, or that I can just immediately kind of skip the steps with the difference just from the counting here, then verify me and let me know if you have any questions about that. All right, I hope this helps. Please reach out if you need anything. Have a great day.